heat capacity. Heat capacity. We talks about specific heat capacity and the various method of calculating the heat capacity. When we talk about heat capacity is defined as the quantity of heat required to raise a unit substances through 1 degree Kelvin or Celsius. I will repeat again. For instance, we have a pot, the beaker, which is containing water molecules, and you put it in the stove or a Bunsen burner. Then we have here is what? A flame, which is containing what? Heat. And if it is supplied in joules to this water, after some time we expect that the molecules of the gas will gain a kinetic energy and they will start moving up with the vapor, being in contact with atmospheric pressure, respectively. And the heat capacity is the amount of the heat energy that will require these water molecules to rise by 1 degree Kelvin or Celsius. So it's the amount of this heat content that will be supplied from the heating or Bunsen burner or gas or cylinder, as the case may be, that will cause rise in the 1 molecules of these water molecules, 1 molecules of the water that is found in the beaker to rise, or pot to rise over 1 degree Kelvin or 1 degree Celsius respectively. And that should give us that heat capacity is equals to M change in theta. We call it equation 1. What is change in theta? Change in theta is equals to the final temperature minus what? Initial temperature. We call this equation 2. Substitute 2 in 1. We have H is equals to, we have what? MC. We have what? Theta 2 minus what? Theta 1, as the case may be. If you are asked to make C subject of formula, what we are going to do is divide both sides by what? M change in theta 2 minus theta 1. We have what? M change in what? Theta 2 minus what? Theta 1. M cancel M. Theta 2 minus theta 1, we cancel theta 2 minus theta 1. And we have the C is equals to H over M bracket T2 minus what? T1, respectively. What is C? C is specific heat capacity, which is in joules, kilogram per Kelvin. That's the C. And we have H. H is the heat capacity that will always be in what? Joules. Then we have the M. M is equals to mass. That will always be in what? In either kilogram or gram, as the case may be. We have the temperature. This is theta 2, which is the final temperature. And theta 1 is equals to initial temperature. And this can be in form of, the SI unit can be in joules or in Celsius, joules or Celsius, as the case may be. That leads us to another thing, which is a specific heat capacity. Specific heat capacity is refers to as the quantity of heat that is required to raise a unit mass of a substances through 1 degree Kelvin. I will repeat again. Specific heat capacity is defined as the amount of heat energy in joules that will require to raise a unit mass of any given substances through 1 degree Kelvin or Celsius. And the formula is equals to Q is equals to MC. We have theta 2 minus theta 1. In some cases, the theta can be used as T, where you have the Q is equals to MC theta 2 minus the theta 1. Then after confuse is the same thing, where we have the Q is equals to MC theta 2 minus theta 1. What you're going to do is divide both side by this. Divide both side by. If you divide both side by, if you want to make C subject of formula, you divide both side by what? M theta 2 minus theta 1. Then we have what? M theta 2 minus theta 1 respectively. Theta 2 minus theta 1. M cancel M. Theta 2 minus theta 1 cancel. Then we have C is equals to theta Q. Q is equals to M theta 2 minus theta 1. We have the same thing there. C is specific capacity in joules kilogram per Kelvin. Q. The Q is the quantity of heat energy, which is the specific capacity. Then we have the M. The M is mass. T2 is final temperature. T1 is initial temperature, as the case may be. That leads us to what are the methods involved in calculating the specific heat capacity. The method involved in calculating the specific heat capacity are just how many? There are 4 in number. The first one is the mixture method. We have mixture method. The second one is we have the ignition method. We have the electrical method. We have the third one is the mechanical method. And the third one is what we call continuous flow method. These are the four methods in calculating the specific capacity. We have the mixture method, we have the electrical method, we have the mechanical method, and we have what? Continuous flow method. Permit me to give each individual formulas. The mixture method of calculating the specific heat capacity, it works on the principle of the heat lost by solid is equals to heat gain by water plus the heat gain by calorimeter respectively. And let's now get the formula. The formula is the heat lost by the solid, which is same thing as MC ms theta s minus theta final is equals to the heat gained by water, which is same thing as MLCL theta f minus theta I plus the heat gained by calorimeter, which is MC the CC theta f minus theta I. So from here we call this one equation 1. If you observe, the theta f minus theta I, the theta f minus theta I are the same. You can factorize them. We have the ms, the ts, theta s minus theta f is equals to ml, the ml cl plus mc cc. We have theta f minus theta I all over. Yes, we do that now. We now make cc to be subject of formula. Cc to subject of formula, divide both sides by mc theta s minus theta f is equals to mc theta s minus theta f. Automatically, theta s minus theta f will cancel theta s minus theta f. The mc cancel mc. We have what? Cs is equals to ml, the cl, plus mc, the cc, theta f minus theta I, all over ms, the theta s minus theta f, as the case may be. Let's now see. This is the formula you are going to use to calculate the specific capacity of a solid. And what is CS? What is specific capacity of solid? Which is joules kilogram per Kelvin. We have here is the mass of liquid, the specific capacity of liquid, the mass of calorimeter, specific capacity of calorimeter, the final temperature, the initial temperature, the mass of solid, the temperature of solid, minus the final temperature. This is the formula to calculate specific capacity of a solid. That leads us to the second one, which is electrical method. In calculating the electrical method, you're using the formula that says the P times T is equals to, that's the power. The power times time is equals to the M. The power times time is equals to what? The Q. The power times time is equals to the H, which is same thing as the power times T is equals to, what is Q? The Q is equals to MC theta 2 minus theta 1, equation 2. Substitute 2 in 1. We have what now? The power times T is equals to MC theta 2 minus theta I. Therefore, what is power? We call this equation 3. What is power? The power is equals to IV. That's current times time. We call this one equation what? 4. Substitute 4 in 3. We have the IV T is equals to MC theta 2 minus theta I. Therefore, if you are asked to make C subject of formula, what I'm going to do is very simple. We are going to divide both sides by M theta 2 minus theta I. The M theta 2 minus theta I. M cancel M. Theta 2 minus theta 1 we cancel. Then we have the C is equals to IVT over M theta 2 minus theta I, as the case may be. This is a formula to calculate specific capacity using the electrical method. And the SI, the C is specific capacity, the I is the current in ampere, the V is potential difference of voltage in volt, the T is time, the M is the mass in kilogram, while the T2 minus T1, which is the final temperature minus the initial temperature, as the case may be. That leads us to the another method, and the method is The method we are going to do for the last one is the mechanical method. For mechanical method to calculate specific heat capacity is we have the mgh is equals to the mgh, or we can say the formula is F times H is equals to Q. We call it equation 1. What is F? From the second law of Newton, F is equals to ma. We call this equation what? 2. And Q is equals to mc change in theta. Change in theta. MC change in what? Theta. Equation what? 3. Substitute 2 and 3 in 1. We have what now? MA, or we say MAG. The MAG times H is equals to MC change in theta. Equation 3. Equation 4. Then we have change in theta. The change in theta is equal to T2 minus what? T1. We call it equation 5. Substitute 5 in 4. We have what? Mg times H is equals to MC theta 2 minus theta I. And if you ask to make M subject of formula, we call it equation 6. Divide both sides by M theta. We have what? M bracket T2 minus T1. We have what? M bracket T2 minus T1. M cancel M. This cancel this. C is equals to mg times H over M theta 2 minus theta 1, as the case may be. M is the mass in kilogram or gram. G is acceleration to gravity in meter per second square. H is the height in meter. The M is mass. And T2 is the final temperature in joules, in kilograms or Celsius. The T1 is the final temperature in T2 minus T1, as the case may be. And that is the end of everything. Thank you so much. My name is Muhammad Nasser Abdul.